Alright folks, let's do number 3 here. A person walks at first at a constant speed of 5 meters per second along a straight line from point A to point 4A. So this is a person, this is from point A to point B. So here's the individual, and he walks at a speed of 5 meters per second. So this is going to be point A, and this is going to be point B. There you go, beautiful. Anyways, and then back along the path, so this is from the time interval from t0 being to 0 seconds, and t1 being t1, whatever that t1 happens to be. It's just the way I'm going to model it. And then it goes from point B back to point A. Let me rewrite that. So that's going to be point A. There you go, beautiful. There you go. So he's going to walk back in this pathway at the speed at 3 meters per second. Beautiful. I just took an edible to come down from my phobia right now, so as a recording, I am a bit high on this video, but anyways, I don't think that really matters. But anyways, what is her average speed over the entire interval? And what is her average velocity over the entire interval? I actually did solve this problem before, and actually, unlike some other videos, I actually did this problem before I pressed the record button. So I know how to solve it, and I think I know how the Ways of Solution manual solves it. Either way, it does match up to the answer in the back. So I'm going to solve it the way I showed you guys. So because in part A, it's asking for the average, well, part B is just going to be the average velocity to be 0, because if it starts from point A to point A, the change of displacement is just going to be 0 over the course of whatever that time interval is. So B is just 0. Let's just get that out of the way. So 0. So what is her average speed over the entire trip? So the speed is a little different. So the speed is the total distance it travels. So I'm going to call the distance 2d. D being from the absolute magnitude, this displacement from point A to point B, and B from the absolute value back to from P to A. So this is going to be the absolute value. And the time interval, I'm going to put T as the capital T, as the whole total time interval. So the whole total time interval, and this would be T1 back from T1 to T2 equals T2. So from 0 to T1 is going to be the time from A to B. So T is going to be T1 added to T, and from B from TA to back to T2. I hope you guys are not that confused about this, because the solving part is straightforward. It's really the setup. All right. So recall that the speed or the average the velocity is going to be the distance over the time. So the time is going to be the distance divided by the velocity. Now I'm going to call the velocity T1 being the distance being d, whatever that d is, over the speed, which is 5 meters per second. T2 is going to be d over 3 meters per second. I know I started explaining, folks, but what we're really doing is taking the 2d divided by d, being the average speed, divided by the total distance it travels over the whole time interval, which is 5 meters per second, added to d over 3 meters per second. Once you work out the units, this would be 2 over 1 over 5 plus 1 over 3 meters per second. So once you work it out, you should basically have this 1 over 5 plus 1 over 3 meters per second. So that's going to be 30 over 15. Wait, what is that? 3, 5, 8 in the bottom. 2 times 15 over 8 in there. So that's 30 over 8, or 1/4, or in this case, what is that? 30 over 15 fourths, 15 over 4, something about 4 times 3 is 12, 12 times 3 is 4, 4 times 3 would be 12. So I know this is going to be 3. 12 plus 3 would be 15, so that's 3/4. 3/4 would be 3.75 meters per second. Anyway, however the heck you guys want to do the math, or just put it in the calculator, who really cares? But, so that's her average velocity or speed.